Now this is where we ended up in our last video. So we see that the integral of this, let's write down the answer and just erase what we did before. It is ln x squared minus 5x minus 24 plus c. So let's write it down here. It is equal to ln x squared minus 5x minus 24 plus 24 plus c. Now the question is, could we also use another method? Could we use integration by parts to do it? Let's try. Can we factorize the denominator function? You remember the what you call it, the AC method. In this case, A is 1, B is negative 5, C is negative 24, because what we have is a function in the form ax squared plus bx plus c. Alright? Now, here, the AC method, we multiply a by c, 1 by negative 24 in this case, we get negative 24. Then we say, can we find two numbers that multiply to give negative 24 and add to give negative 5? If you think about it, we would have 8 and 3. One of them is negative because they multiply to give negative 24. But they add to give you negative 5. Here it is the 8 that would have to be negative. So it's negative 8 plus 3 is negative 5. So negative 8 and 3 will work. So we have x squared minus 8x plus 3x. It doesn't matter if you had put plus 3x minus 8x. You get the same answer. Remember that? Minus 24. So here now. Oh, let me continue erasing what we had here before. So here, what we have, we factorize this, so we have x outside the bracket, x minus 8. Then we're going to have another bracket with the same thing. When we factorize these two, we have plus 3, and inside the bracket, x minus 8. You have to remember your factorization there of quadratic functions, right? So what we have is x plus 3, x minus 8. Okay, so this can be rewritten as the integral of 2x minus 5. So it's the integral of 2x minus 5 over x plus 3, x minus 8 dx. Now writing it in partial fractions, what you would have is a over x plus 3 plus b over x minus 8. Alright? So, that's what you have. Now, it would be the integral of all of this. Right? Dx. What we want to do is find a and b. It keeps jumping back up here. Now, if we multiply both sides by x plus 3, x minus 8, let's drop the integral sign for now. You would have 2x minus 5 because the x plus 3, x minus 8 would cancel itself, equal. Then a over x plus 3 multiplied by x plus 3, x minus 8, right? Plus b over x minus 8 multiplied by x plus 3, x minus 8. Let me rewrite this 8 here. X minus 8. X minus 8. X plus 3 would cancel x plus 3. X minus 8 would cancel x minus 8. what you would have is 2x minus 5 equal a times x minus 8 plus b x plus 3. Alright? Now, let's get rid of a. How do we do that? We're going to have x minus 8 equals 0. So, let x equal 8. So we have 2 by 8, 16 minus 5 equal, it would be 0. Because what we would have is a times 8 minus 8 plus b times 8 plus 3. Alright? 16 minus 5 is 11 is equal to 0 plus 8 and 3, 11, 11b. So we can see here that b is equal to 1. If we divide both sides by 11, b is equal to 1. Alright? Now, what about a? Let's get rid of b. What do we do to get rid of b? We let x equal negative 3. So, let x equal negative 3. What would happen here? We'd have 2 by negative 3, which is negative 6. So negative 6 minus 5. Negative 6 minus 5 is equal to a times negative 3 minus 8. So it is a times negative 3 minus 8. Then plus b, negative 3 plus 3. So plus b, negative 3 plus 3. See that? Negative 6 minus 5 is negative 11 equals negative 3 minus 8 is negative 11 a plus 0. So a, in this case, a would also be equal to 1 when we divide. So a is 1 and b is 1. So here now, what we would have, we remember that a is 1 and b is 1, so let's just erase. We need to save space. Let's just erase the work and go back up here. Now that we know that a is 1 and b is also 1. I'm going to use partial fractions. Alright? So, what we have is the integral of 1 over x plus 3 plus 1 over x minus 8 dx. Alright? Which is equal to, well, we could separate them, finding the integral individually. Integral of 1 over x plus 3 dx plus the integral of 1 over x plus 8 dx. See that? What does that give you now? This is ln x plus 3 plus ln x plus 8 plus c. Did I write the plus c up here? Okay, good, good. I remember. Alright. Now, ln x plus 3 plus ln x plus 8. Can we combine them? Let's be reminded of something. What is ln 2 plus ln 3? Just a reminder of our logs, in case we've done logs a long time ago and don't remember the rules. This is, let me make this the full calculator. ln 2 plus ln 3 equal 1.79. Now let us find ln 6 and see what we get. Same 1.79. Alright? So this is the same as ln 2 times 3. Remember that rule? ln A plus ln B is the same as ln AB. Now, what happened here? Now that you remember it, what happened? ln x plus 3 plus ln x plus 8 is the same as ln x plus 3 times x plus 8 plus c. The answer would have the plus c, so let's not forget it. Now, this is the same as ln. Multiply these, x times x, x squared. Let's put a bracket around it. So x times x is x squared. X times 8 is 8x. Oh, by the way, hold on. What do we have? X minus 8 is x plus 3x minus 8. Why did I change it to plus? That was a mistake. It's an x minus 8. Alright? Should be a minus 8. This should be a minus 8. Alright? This here should be a minus 8. Alright, so my mistake there. So x times negative 8 will be negative 8x. Then 3 times x, you have plus 3x, and 3 times negative 8 minus 24 plus c. So the answer is ln x squared, and this is minus 5x because negative 8x plus 3x is negative 5x, minus 24 plus c. ln x squared minus 5x minus 24 plus c is what we get. Is it the same thing? ln x squared minus 5x minus 24 plus c. Same thing. So we have solved this using substitution in the previous video. And we use partial fractions now, and we see that we get the same thing. So we have a choice, whichever way we want to do it. Unless you're told to solve it by a partial fraction, or specifically to solve it by substitution.